Let's see, what is today? The 9th, October 9th. Cool. So we're gonna go and get some definition stuff going here first, and there's gonna be a lot of identification. So today's lesson is actually gonna be a lot like that very first lesson we had at the very beginning of the year, where we talked about points, lines, and planes and all that kind of stuff. So today's lesson is very similar to that. It's a lot of identification and naming things. So here we go. Parallel lines are two coplanar. So there's two words here. Two coplanar. What does coplanar mean? Coplanar means the same plane. Yep. Two lines that are on the same plane. That's what coplanar means. That do not what? Parallel lines never what? Yeah, they never intersect. Good. So two coplanar lines that never intersect. And if you look on here, there's a symbol to show that line AB is parallel to line CD. What symbol is on each line?
The extra arrow.
Yeah, so arrows. So these arrows in the middle of the lines here, listening please, these arrows right here indicate that those two lines are parallel to each other. They will never cross. So symbolic notation is like this. We're going to say line AB. So remember how to write the name of a line. You do two capital letters. And for line, you do a line above it with arrows at each end. So line AB. And then the symbol for is parallel to is basically two lines that are right next to each other like that. You can do them completely vertical. I usually lean them forward just a little bit so they don't look like L's or ones. And so that symbol means is parallel to. So line AB is parallel to line CD. There we go.
Those two lines be parallel.
There you go. Thank you. What's up? Yeah, these two lines are parallel to each other. Yep. All right, so that's a little bit of notation to get started here. Moving on, parallel planes. So, same idea as lines. So if you think about, first of all, these are planes that do not intersect. So planes that do not intersect. So if you think about the walls in this room, this wall over here, that wall over there, they're parallel, they will never intersect. The symbolic notation here, remember, if you're going to name a plane, you either need 3 points that are not all in the same line or a large scripty cursive type letter. So we can say plane J, because we don't have any points on these planes. We just have them named by the capital script type letters. So plane J is parallel to plane K. The plane J is parallel to plane K. All right. So that's what we got for parallel. And I think everybody at this point, you all knew what parallel meant. The next one is the idea of skew. Has anybody ever learned about skew lines? All right. Because there's more than one way for lines to not intersect. They could be parallel or they could be skew. So with parallel lines, the lines have to be coplanar. With skew lines, they are non-coplanar. So non-coplanar lines that do not intersect. Meaning they're not going to intersect, but they're also not going to be running in the same direction. For example, I'm going to use a highlighter here. Line TW right there, and then QR would be parallel because they're running in the same direction. However, Yeah, PQ would work. Yes. So TW and PQ would be skew because they're not running in the same direction. So they're not parallel, but they also won't intersect because one's up here and one's down here. So we can say TW, so line TW and line PQ. It's kind of like, listen up, it's kind of like on I-84 when you go past Mosier, right? I-84 goes underneath the overpass that goes across Mosier, right? So those two, listen up. So there's an example of skew. So I-84 and Mosier, right? You got the Mosier overpass and I-84 goes underneath it. Those two do not intersect because if they did, there would be massive accidents all the time, right? If they actually intersected. So one is above the other. And so that's what skew means. So anytime you see an overpass or a bridge going over a road, those lines would be skewed to one another because the lines themselves, the roads are not going in the same direction. However, they're not running into each other either. So they don't intersect. So two more examples from here. What do we think? SR and UV. Yeah, that works. SR and UV. So line SR, line UV. By the way, there's more than just 3 examples on here, but we're just going to name 3 of the ones that are on there. WV and QR. Yeah, that works. Nice. So WV and QR. Nice. So all right. WV and QR. There are more. We're not going to name more. So what we have to do to finish off this page here, we're just going to be naming examples. Oh, there you go. We're going to be naming examples of the things that it tells us to. So like I said, this lesson is very much like the very first lesson that we did at the beginning of the year where we learned how to name points and lines and planes. Now we're learning how to name parallel lines, parallel planes, and skew lines. So let's have a look at number 1A. It says name all segments parallel to segment AE. So AE is vertical. So all of the other vertical segments would be parallel to that. So yeah, let's see. EF, no. FG, no. BF, yes.
Wait, I thought they were going to be parallel.
Well, AE and BF are because they're vertical. So if they're both straight up and down, then they got to be parallel. So what's that? That's skew. We're looking for parallel. Yeah. So BF, HD, and CG. Those segments would all be parallel to AE. All right, now the next one says, give 2 examples of parallel planes. So this is essentially a box, right? Yes. So with boxes, parallel planes would be like the top and the bottom. Those would be parallel planes. Or the left side and the right side. Those would be parallel planes. Or the front and the back. Those would be parallel planes. So if you're going to name 2 planes, you're going to name 1 plane. You just got to pick 3 points out of the 4. You don't need to use all 4. So let's go with the top and the bottom. Pick 3 points from the top. H, F, G. All right. And then if we're going with top, the one that would be parallel plane-wise would be the one on the bottom. So pick 3 from the bottom, A, B, C. All right. So plane HFG and plane ABC. Those would be parallel planes because one's the top of the box and one's the bottom. Somebody give me an example of 2 more parallel planes. We've used top and bottom already. So AEF, so that's the front. And DHG would be from the back. Good. Cool. So front and back. Yep. All right. Now C, I think C is going to be maybe the most challenging one on here because it says to name all segments that are skewed to GH. So here's the way you can think about this. With GH, you cannot pick any other line that is going left and right. If we're going with skew, listen carefully. If you're going with skew, it cannot be going left and right. So EF, AB, and DC are automatically out because those are all parallel. The other thing we want to make sure is none of them actually intersect. So we can't choose any of the lines that are on the top. So HE does not work, GF does not work, GC doesn't work, and HG doesn't work. Skew, yeah. So basically we're looking at the two on the front that are vertical.
Hey, keep digging.
Yeah, let's try to pay attention. I can do a seating chart if we need to. Okay, so two vertical lines up front, those ones would be skew to HG. And then these two here going front to back on the bottom of the figure would also be skew. So there's four lines or four segments that are skew to GH. We would have AE, segment AE, segment FB. We got segment BC, and we got segment AD. Those are the segments that would be skew to HG. Everything else is either parallel or actually intersects with it. Yeah, maybe. What's that?
They are parallel or.
Does it matter what? You mean like the order of the letters? No, no, we could have said EA, BF, CB, and DA. Yeah, that's fine. Okay. Question back there? Got it. Okay. The next figure is a little bit more challenging just because we have not just 6 faces to it. We've got a front and a back, and then there are basically 5 rectangles all the way around it. So there's 7 different faces for this thing. So we're looking for all segments that are parallel to JK. So JK is here. OP, and that's it, isn't it?
Yeah.
I think that's it. So segment OP is parallel to segment JK, and it's the only other one on here that's parallel to it. Then it says to name all other segments parallel to NS. Now,
MRLQ. I said it first.
MR.
I said it first already.
I don't care. So MR, LQ. What else? Mabel. JO, yeah. And then one more. Vicky? Yeah, KP. Nice. KP. There we go. So the segments parallel to NS would be MR, LQ, JO, and KP, because those are all going from basically the front to the back of one pentagon back to the other. So those 5 all the way around would be parallel to one another, because they're all heading in the same direction. And even though they might not really look like it, they are all coplanar. So it might not look, first of all, it might not look like that KP is on the same plane as MR, but it actually is. Here, let me get my, just because it's not shown doesn't mean it's not true. So for example, if I were to draw from K to M like that, and then from R down to P like that, we could end up making a plane like that. So there is a rectangular plane that matches up with those. It's just not shown on this particular figure, even though it does exist. So those ones would be considered to be coplanar. All right, let's go ahead and finish up this first page here. We have name a plane parallel to JKLM.
Yeah, I got you.
What is it? OSRQ? Yeah. And we actually only need 3 letters. I don't know why they use 4 letters here, to be honest. That's kind of annoying to me because we only need 3. So let's just choose 3 from the back. How about like OPQ?
So
OSR is the same one. Yeah, that's fine too. OSR and OPQ are the same plane.
OPQSR.
So there's 5 letters. We just need 3 of them. I don't know why they did 4. We'd only need 3. So actually, I'm just going to get rid of the M. I'm going to call that JKL because
Wait, N in it too?
N would be on the front. Yeah.
No. SR.
Okay. Next one.
OSR.
Write these down on your own first, and then we'll double check in a minute. So name 4 segments skew to RQ. 4 segments skew to RQ. Try to find 4 segments skew to RQ. Just write them down for now, and then we'll check back in a minute. I believe there are more than 4 segments that are skew, but just name 4 of them.
I'll pay you the wedge.
All right, so here are 4 segments that are skew. You might not have the exact same ones. If you wrote something different and you are unsure, let me know.
I got NN. I got K.
NM, yeah. PK is skew to RQ.
I got SR.
Let's see. SR, no, SR intersects with RQ.
QL.
QL with RQ, no, because it intersects at Q. So if they touch, it doesn't work. Mabel? SO for RQ, yes. And then JO, yes. Those will both work as well. SO and JO both work. Any other questions on anything that you wrote? Yeah, Mabel? Yeah, everything on the front works except for ML, because ML is parallel to RQ, but if you use NM, NJ, JK, LK, those are all skew. Yeah. MR, no, because R intersects with RQ. So if there's the same point between the two, it won't work. So they can't intersect and they can't be parallel. Any other questions for 2D? ML, yes. No, ML, no. Sorry, it's parallel. ML is parallel to RQ. Yeah. So like NM works, NJ works. So everything, so Vicky, every segment from the front shape works except for ML. So like LK works, JK works, NJ works, NM works. So if you wanted to do your 4 segments, you could do all 4 segments on the front except for ML. There will be, yeah. All right, let's turn the page. So the other big part of what we're going to learn today are the different types of angle relationships that you get when you have what's called a transversal. So let's take a look. First of all, a transversal is just a line that goes through 2 or more other lines. So for example, here, which of those 3 lines would be the transversal? T, yeah. So line T is our transversal here. Line T is our transversal. All right. Now, the rest of today, we are going to be identifying different types of pairs of angles that we get when you have 2 lines and then 1 line that goes through the other 2, I should say. So one of the types of angles that we end up with. So first one up here, example, line T. First thing that we're going to talk about are corresponding angles. So same diagram that we see up top here. It just has angled numbers now. So we have angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So there's 8 angles that we get. And corresponding angles, the definition right here, it says that they're angles that are on the same side of the transversal. So angles on the same side of the transversal would be like 1, 4, 5, and 8. Or if you go to the right side, 2, 3, 6, and 7. But they have to be what's called in the same position. So basically it means upper left here would be angle number 1. And if we go down to the upper left of the next group down here, that would be angle 5. So angle 1 and 5 would be corresponding. They're both on the left side, and they're both on the upper sides of their respective lines. So left side above angle L, that's angle 1. Left side above angle M, that's angle 5. So those two angles would be corresponding. It's basically like every other angle on the same side of the transversal. So 1, skip 4, go to 5, 1 and 5. 4, skip 5, go to 8, so 4 and 8. So on the left side, we have angle 1 and angle 5. So those two would be corresponding. We have angle 4 and we have angle 8. So angle 4 and angle 8. Those would be corresponding as well. What about on the right side of the transversal? 2 and 6, good. And then 3 and 7, nice. So angle 2 and angle 6. Then we've got angle 3 and angle 7. So those are the 4 sets of corresponding angles in this particular figure. So they have to be on the same side of the transversal. And it's basically like every other on the same side of the transversal. The next ones, I'm just going to go ahead and do a little shading here with my highlighter. So first of all, the pink, everything in pink, those are interior. I'm going to go blue out here. Those would be exterior. So the angles that are in between the two lines, the ones that are on the inside of between the two lines, those are interior. The ones that are outside the two lines are exterior. There's 4 in between, 3, 4, 5, and 6. There are 4 on the outsides, 1, 2, 7, and 8. Now, an alternate interior angle are angles that are on the inside. By the way, we're pairing up angles. There's never more than 2 that we can pair up. So we're pairing up interior angles that are non-adjacent, meaning they're not right next to each other. So like 5 and 6 don't work, 3 and 4 don't work because those are adjacent. And they're on opposite sides of the transversal. For example, 4 and 6, exactly. So angle 4 and angle 6. So 4 and 6 would be alternate interior angles. And also what? 3 and 5. Nice. Angle 3 and angle 5. The next ones are alternate exterior angles. It's the same idea, except they're on the outside this time. So what do we think? 1 and 7. Yeah, they're like diagonally all the way across the diagram. So 1 and 7. So angle 1 and angle 7. And the other 2 would be what? 2 and 8. Good. So angle 2 and angle 8. So we've got corresponding, same side of the transversal, every other. We got, what's that? Which one? The interior and exterior? Okay, so alternate interior. There are angles that are, 2 of these 4 match up. They can't be next to each other, non-adjacent. If they are next to each other, that means they're a linear pair. We already have that one, so we're learning something new. So 5 and 6 don't work, 3 and 4 don't work because those are adjacent. They're on opposite sides of the transversal. So like diagonally across from each other on the inside. 3 and 5, 4 and 6. Same thing with alternate exterior, diagonally across from each other all the way across the diagonal. So 2 and 8, 1 and 7. Okay. And then the last one we're looking at are consecutive interior angles. And these are also non-adjacent, but they are on the same side of the transversal. For example, 4 and 5. So angle 4 and angle 5, those are not adjacent because they don't share a side for the angle, but they are on the same side of the transversal and they're both on the inside. So angle 4 and angle 5. And on the other side, we'd have angle 3 and angle 6. So those are the 4 types of angle relationships that we end up with. Now, this is in addition to all the ones that we know already, because we have linear pairs, and there's linear pairs all over this diagram. Two angles that form to make a straight line. So like angles 1 and 2, those are a linear pair. 1 and 4, 2 and 3, 3 and 4, 5 and 6, 6 and 7, 7 and 8, 5 and 8. There's a whole bunch of linear pairs going on there. Also, there's a lot of vertical angles here too. Don't forget about vertical angles. Those are the ones that are diagonal from each other when 2 lines intersect. So 1 and 3 would be vertical. Those are equal to each other because vertical angles are congruent. 2 and 4, 5 and 7, 6 and 8. So all the stuff that we know about linear pairs and vertical angles still is true. So don't forget about those things because we're going to keep using that stuff. We're just introducing new things in addition to what we already know. All right, now we get to go through and identify the angle relationship. And if there isn't one, you write none, because sometimes we don't have anything that matches up with what we've already learned. So basically we have 6 types of angle relationships now, according to these diagrams. We have the 4 that we just learned, plus linear pairs, plus vertical angles that we already learned before. So here we go. Angle 1 and angle 8. Alternate. 1 and 8 are on opposite sides of the transversal. And they are outside of these 2 lines. So that would be alternate exterior. And I'm going to abbreviate that. Alt. And then EXT for exterior. Alt X. A lot of abbreviations. You're welcome to use those as well. Yeah. Alternate exterior, you don't have to. If you want to, you can. If you're asked to name angles, then you absolutely need to. But if you're being asked to name the angle relationship, you don't have to use the symbol. Naming the angles themselves, yes. Naming the relationship, not necessarily. How about 2 and 3? Consecutive interior. Good. Oh, by the way, there's another name for consecutive interior that I will use as well. It's called same side interior. That's the one that I grew up learning when I was in school. Consecutive same side means the same thing. Abbreviating same side, though, can be a little bit easier because usually I just do SSINT for same side interior. SS and then INT for same side interior. If you want to write consecutive interior like CONS, that's fine for consecutive if you want to do that. I will generally use same side though. How about 5 and 7? Those are corresponding, yeah. I just usually do CORR for corresponding. Those are corresponding because they're on the same side of the transversal. By the way, R is the transversal because it's the one that goes through the other 2. So line R is the transversal. 5 and 7 are both on the underside of the transversal. And it's 1's out here, and then we skip 6 and we go to 7. So that would be every other on the same side of the transversal, meaning corresponding. How about 2 and 7? Alternate interior. Good. So that'll be alt and then INT for interior, alternate interior. All right. Okay. How about 1 and 3? Also corresponding. And then 6 and 7? Consecutive interior, yeah. Same side interior, consecutive interior. Nice. Are there any questions on diagram 1? Before we look at diagram 2, because diagram 2 becomes more challenging. There are 4 lines now instead of just 3. What that means for us is that this diagram on problem number 2 can be viewed in a few different ways because every single line here is a transversal. With number 1, R was the only transversal in number 1. Here, every line is a transversal. A goes through lines D and, oh, this one right up here is line C. It wasn't named. So that's line C. So goes through line D and C. B goes through line D and C. C goes through line A and B, and D goes through line A and B. Every line here is a transversal, which makes it a little bit more challenging. However, I'm going to give you some clues as to how you can figure out what's going on, because there are 16 angles here, and I don't know about you, but that looks really cluttered.
Yeah.
And it's like kind of confusing to figure out what's going on, right? So what you need to do here, and what I'm going to suggest, is have like a small piece of paper, or maybe use your hand, or like a calculator or something to cover up the parts that you don't need when you're looking at the 2 angles that you need. So for example, if we look at angle 5 and we look at angle 13, those are both over on the right side of the image, right? They're both on line B, which line B would be considered the transversal in this particular scenario with angle 5 and angle 13, which means none of the angles on the left are needed for this problem here. So 2A, we don't need anything on the left side of this diagram, so we can just cover that up. Any part of the diagram you don't need, you can simply cover up, and it makes it a lot easier to look at visually. And like Vicky said a moment ago, and like Rolf just said, 5 and 13 are corresponding because they're both on the left side of the transversal, which in this case is B. B would be the transversal. They're both on the left side. And then we have 5 skipping 7 going to 13. So every other on the same side of the transversal means corresponding. Good. The next 2 we're looking at are angles 7 and 14, which are still on that same transversal. So we can keep the left side of the diagram all covered up. And those are alternate interior. Good. Because they're both in between lines C and D. Those would be interior angles. They are diagonally across from each other across that transversal of line B, which means they are alternate interior. Nice. Let's see. The next 2 we need are 9 and 16. I see 16, but I don't see 9 because I have it covered up. So 9 is down there. So that means this time we can cover up the top. And now, hang on, before we answer it, now line D is our transversal. So if we're looking at 3 and 6, oh, sorry, 3 and 6. I've skipped to 9 and 16. Sorry, 3 and 6. My bad. We need to cover up the bottom for this one. 3 and 6, there we go. Those are alternate exterior. Yeah. By the way, alternate exterior can be really confusing if you're looking at the entire diagram without covering up part of it. Because if I take this away, so take a look as it is right now. Angle 3 does not look like an exterior angle right now, but in the context of this, it is exterior. So covering up the stuff that you don't need can be really valuable in terms of what is exterior versus interior. So physically covering the part that you don't need to see is really, really helpful a lot of the time here. So angle 3 and 6 here, they're on opposite sides of the transversal. And they're exterior because they're outside of lines A and B. A and B would be the outside inside, exterior interior lines here. So because they're outside of those 2 lines and they're diagonally all the way across the diagram, those would be alternate exterior angles. Good. Now we can look at 9 and 16. Yeah, alternate exterior again. Nice. So 2 in a row, alternate exterior. So this is how I handle big diagrams where I'm like trying to figure out what's going on. Just cover up the stuff that you don't need. So the other angles there are not necessary because those are the 2 angles we need down there, 9 and 16. Let's see, 4 and 7. 4 and 7 are up here. Same side, interior, yeah. So same side or consecutive interior. Good. All right, let's do a couple more here. Actually, you know what? I want you to try the rest of these on your own. Try F through J. Try F through J. Try F through J. And then we'll quickly fill in the next page and then you get your assignment. All right. I know that wasn't a whole lot of time, but let's take a look. Starting with F, right? 2 and 10. Yes. So 2 and 10 corresponding for F. G, same side interior. H and I are both none. At the bottom, it says it's important that the angles must belong to the same transversal. If there are different transversals with the angles that you're looking at, then they can't have any of those relationships. So with 6 and 11, 6 is here, 11 is over here, and those are on two completely different sets of intersecting lines, which means they have no relationship whatsoever. Angle 6 could only have a relationship with any angle right here, or 1, 2, 3, and 4, or 13, 14, 15, and 16. Angle 6 cannot have any angle relationship with 9, 10, 11, or 12 because they are on completely different intersecting lines, which means they do not share a transversal. Same with 4 and 13. Same with 4 and 13. 4 is with this group up here, 13 is down here. Two completely different sets of intersecting lines. They can't have a relationship between the two. However, the last two, 4 and 9, would be on the left side, right here and here. So those would be alternate interior angles for J, angles 4 and angle 9. All right. Any questions on those before we take a look very quickly at the last page? All right. Flip it over. Let's go ahead and do these ones very, very, very quickly. So name the transversal with angles 1 and 12. So I'm going to cover that up. No, which one is the transversal? What line is the transversal?
L.
L. Good. So these first ones, it wants you to name the transversal. So for 1 and 12, L is the one that goes through lines J and K. Let's see, for 3 and 6, J would be 3 and 6, J would be the transversal. Oh, I can't forget about the line symbol. So line L, and then 3 and 6, line J. 7 and 15, line M. And I'm guessing the last one is line K. Yep. One of each, as is usually the case with this kind of stuff. So those are the transversals for each of those sets of angles there. We don't need to say what the relationship is between them. All right, now, all it wants us to do here is name some corresponding angles. We're not going to be able to name all of them, but we can name some of them. Which one? 1 and 9. Yes, so angle 1 and angle 9. Okay. Let's choose a different transversal. 5 and 13. Sure. Angle 5 and angle 13. Let's choose a different transversal. That works as well. Angle 12 and angle 16. And then one from the final transversal.
11-3.
From the top figure here.
7-3.
7 and 3, yeah. So angle 7 and angle 3. We'll go ahead and stop there. We'll just do 4 for that one. In fact, we'll only do 4 for each of these. We'll do 1 example per transversal. How about that? So alternate interior angles.
211.
2 and 11. Okay, so that's angle L taking or transversal L taking care of there. So angle 2 and angle 11. 8 and 13. Okay, so that'd be transversal M. So angle 8 and angle 13. 13 and 12. That takes care of transversal K. Angle 13 and angle 12. And then we need one from the top along transversal J. 11. Wait. 3 and 6. Yeah, 3 and 6 would be alternate interior on transversal J. Good. So angle 3 and angle 6. Cool. So 4 examples for each of them here. All right. Now alternate exterior angles. Which ones? 1 and you say 1 and 8? Yeah. So angle 1 and angle 8, that would be from transversal J. So 1 and 8 will be alternate exterior. So angle 1 and angle 8. Nice. 7 and 14, that would be from transversal M. I like that. Angle 7 and angle 14. So we've got J and M. Now we need one from L and one from K.
15, 10.
15 and 10, that would be from K. All right.
10 and 3.
10. And then for L, 10 and 3. Yeah, 10 and 3 works as well. There we go. Get ourselves one example from each transverse. All right, last one we need are consecutive or same side interior angles.
8 and 15.
8 and 15. Okay, that would be from transversal M. So angle 8, angle 15.
13, 11.
That would be transversal K. 13 and 11. By the way, it doesn't matter what order you put the angles in. You can smaller and larger, larger and smaller. 2 and 9 from transversal L.
3 and 5.
3 and 5 from transversal J. Cool. All right. So I'll leave those up there for you to get written down. If you don't have them yet, I'll get the assignment handed out. We've got about 8 minutes left. So get these handed out. The first side is identifying parallel, skew, that kind of stuff. And on the back, it's identifying angle relation. So this one, again, this looks a lot like that very, very first lesson that we had at the beginning of school. Yep. He did. Yeah. Really? All right, let's come back. All right.